Hello everyone, I am Haiying Zhe from Institute of Data Science and Knowledge Engineering, School of Computer Science in Beijing Institute of Technology. In this session, we will discuss about the fourth paradigm of scientific research, which is a data-intensive research method. Jim Gray, he is the founder of Relational Database, and he is also a Nautica sport enthusiast. January 28, 2007, he was disappeared on the sea forever. And just 11 days before that, January 17, 2007, at the NRC CSGB National Research Council Computer Science and Telecommunications Board meeting held in Mountain View, California, he delivered his last lecture, The Revolution of Scientific Method. Divided scientific research into 4 types of paradigm. Paradigm means a certain norm that must be followed or a routine that everyone uses. Followed by experimental induction, model deduction, simulation and data-intensive scientific discovery. Data-intensive scientific discovery. Among them, the last data-intensive is what we now call scientific big data. Thousands of years ago, science was empirical. People do the science by describing natural phenomena. Like in ancient China, farming was done by observing celestial phenomena. Last few hundred years, theoretical branch using models, generalizations. From the primitive drilling wood to make fire, it developed to the early stage of scientific development during the Renaissance, represented by Galileo. It is difficult to complete a more accurate understanding of natural phenomena. Science began to try to simplify the experiment model as much as possible, remove some complex inference, and leave only the key factors. For example, smooth enough, enough long time, sufficient thin air, and so on in our physical learning, which is the inexplicable condition description, and then sum up through calculus. This is the second paradigm of scientific research. This research paradigm lasted until the end of the 19th century, and it was perfect. Newton's 3 laws successfully explained classical mechanics. Maxwell's theory successfully explained electromagnetism, and the classic physics building was magnificent. But after the emergence of the quantum mechanics and the theory of relativity, which focused on theoretical research, surpassing experimental design with extraordinary brain thinking and complex calculations. As the difficulty of verifying theories and higher economic investment, scientific research began to appear incapable. In the middle of the 20th century, von Neumann proposed a modern electronic computer architecture, and the model of using electronic computer to simulate scientific experiments has been rapidly popularized. People can deduce more and more complex phenomena by simulating. Typical cases include simulated nuclear test and weather forecast. As computer simulation increasingly replaces experiments, it has gradually become a conventional method of scientific research, which is the third paradigm of scientific research. A major step in the use of computational science was taken when it was realized that non-mathematical models could be simulated, as well as mathematical ones. That is, rules other than mathematical equations could be incorporated into computer programs and stepped through simulated time to see what happens to the state of the model. For example, traffic simulation can predict where bottlenecks and other problems may occur. Even simple rules can generate complex behavior, making it very valuable to observe the output of the simulation to understand what the rules imply. On the other hand, give a set of data, either observed or human-entered. Can computer help us find rules to explain the data? The future development trend of science is that with the explosive growth of data, computers will not only be able to do simulation, but also analyze and summarize and generate theories. The data-intensive paradigm should be separated from the third paradigm and become a unique scientific research paradigm. The method of scientific research is called the fourth paradigm. The fourth paradigm of scientific research and the third paradigm of scientific research both use computers to perform calculations. What is the difference between these two paradigms of scientific research? What is scientific problems? What are the scientific hypotheses? This is first to propose possible theories, then collect data, and then verify them through calculations. The fourth paradigm based on big data is to first have a large amount of known data and then calculate the previous unknown theory. In the big data era, written by Victor Meyer-Schaumburg, it is clearly pointed out that the biggest change in the big data era is to abandon the desire for causality, which are cause and result, and focus on correlations instead. According to the existing mechanism understanding, the formation of haze weather is not only related to the chemical composition of the source atmosphere, but also related to the terrain, wind direction, temperature, humidity, and meteorological factors. Only these limited parameters have exceeded the ability of conventional monitoring and can only be simplified and artificially removed some seemingly unimportant factors, and only some simple